In this video, we will discuss about source-free circuits. So what is source-free? Source-free circuit generally refers that there is no voltage or current source present in the circuit, then how the circuit will behave. So simply when there is no source, for example it is a current source or voltage source, then what are the remaining components are available? Possibly a resistor, capacitor and inductors. So a circuit that behaves without source. So without source we can call it as a passive circuit, but still how it works? How it works in the sense stored energy in the capacitors, stored energy in the inductors, they will start discharging through the circuits, which means we are suddenly removing a source from the given from the circuit, then how the capacitor or inductor they discharge the stored energy when there is no external voltage forcing or in the circuit. That is actually called source free circuit. So that is what we are going to calculate, discharge of energy stored in circuit elements. Elements could be possibly or probably capacitors and inductors. So with capacitors and inductors, what are the types of source free circuits available? So first one is we have source free RC circuit, which means we have only capacitors and resistor combinations, or the other way is we have inductor and resistor combination, that is called source free RL circuits. So first let us consider what is source free RC circuit. From there we'll extend our discussion into other types of source free circuits. So simply as we mentioned now, source free RC circuit nothing but it occurs when DC source is suddenly disconnected from the circuit. When the DC source is suddenly disconnected from the circuit means till at the point where when the DC source is suddenly removed, till then the capacitor or inductor present in the circuit is charging to its maximum value. But as far as RC circuit concerned, we have only capacitor and resistor combination. So we can consider that before the source is suddenly removed, we have charging phenomena happens in the circuit. So the stored energy is there in the capacitor, and that will discharge now once the source is removed. So the stored energy will find a path to discharge the energy. So how the discharge happens, at what rate the discharge happens, that is what we are going to see in the source free RC circuit. In general we can say how this particular circuit, only R and C circuit now behaves when there is no source. That is called source free RC circuits. So first let us assume at t equal to 0. So at t equal to 0, we assume that the initial voltage V of t, or which is equal to V of 0, which is equal to V naught. So at t equal to 0, the source is disconnected. Okay, and usually we know what is the energy stored in the capacitor. We can calculate in terms of half into C V square. So initial energy at t equal to 0, it is assumed as V of 0. V of 0 is equal to V naught. So V naught is removed from the circuit. Okay, so if removed from the circuit means whatever the energy stored here, that is equal to V naught now, which is considered as a initial voltage. And now apply KCL at this node point. Okay, because both starting point of resistor and capacitor are same point, so they can consider as a parallel circuit. So we can apply KCL at this particular location to find out what is IC and what is IR. So as far as KCL concerned, both are outgoing current, it is assumed. So IC plus IR is equal to 0. There is no incoming current for this particular circuit. Okay, and IC can be written in terms of C into dV by dt, and normal I can be written in terms of V by R according to Ohm's law. And still if you do further analysis, mathematical analysis, which means bringing C to the next side, which means we are taking C common, so C comes in the denominator side. Okay, it is a mathematics. If you take C outside, then C must be here, so that is over here, and then keep this dV by dt here and bring this to right side. This will be minus V by RC, and bring V term one side, T term the other side, then dV by V is equal to minus dt by RC, and to cancel the differentiation we can take integration, and when you take integration this will be dV by V is equal to ln of V, and here you can get 1 by RC is constant, so you can take 1 by RC outside with integration dt, and T will be, dt will be T plus ln of a is a ln constant. Okay, assume that, and bring both ln to the left side. You will get ln v by a is equal to minus t by rc, and take power of e to cancel this. Then if you take power of e, then ln cancel, this will be e power minus t by rc, and we'll have only v by a, and bring a to the right side, this will be a into e power minus t by rc, and assume that v of t is equal to a into e power minus t by rc. And now a is replaced with the initial voltage v0. The reason is, so this is the rate at which the energy is either it is discharging or storing. Since it is e power minus, this is discharging, because the value of e power minus 1 minus 2 goes on decreasing the value of this constant. So initial value is v0, assumed as v0 here, that is the stored energy in the capacitor. So that will change with the rate of e power minus t by rc value, that is the rate of discharging. And why I say it is discharging, because it is e power minus t. You just check your calculator, if you put e power minus 1, you will get some value. E power minus 2, the 2 value is less than e power minus 1, so the value will be keep on reducing. Okay, so in what rate the value is reducing, it is exponentially decays. For example, as t increases, okay, as t increases time from 1 second, 2 second, 3 second, and so on, then the rate at which the v0 initial voltages starts decreasing. You got my point? So this is initial voltage, and how this initial voltage is discharging. Initial voltage means that is stored in capacitor. How the stored energy is discharging through the resistor at the rate of e power minus t by rc, v0 into e power minus t by rc. For a case, assume that t by rc value is equal to 1, which means e power minus 1. So e power minus 1 value is 36.78. Okay, in terms of percentage, we can call it as a 36.78 percentage. And if you put e power minus 2, minus 3, and so on, the value will keep on decreasing. At what rate, that can be identified from here. So for that, now we assumed that t is equal to tau. T is equal to tau means tau is assumed as rc. Why? Because if you want to know e power minus 1 value, then t must be equal to rc, so that tt, which means both value t and rc are equal, then they get cancelled, you will get e power minus 1. For that case, we assume that rc is equal to tau. Okay, if rc is equal to tau, and assume that t value is equal to tau, which means t is equal to rc, we will get e power minus 1, and e power minus 1 is 36.78 of its original value. So this is 36.78% of the original v0 value, which means initially if it is 100%, for example, one v0 is nothing but 100% v0 is stored, but after 1, which means e power minus 1, the value is changed into 36.78%. And if you increase this ratio, t by rc ratio, in terms of 2 tau, okay, then what will happen? Then this will be rc value is equal to, which means t is equal to 2 times tau. Then what will happen? This is 2 divided by tau value, so rc and 1 rc will cancel, so you will get e power minus 2. So e power minus 2, minus 3, and so on. So if t equal to rc, you will get e power minus 1. If t is equal to 2 times rc, then e power minus 2. If t is equal to 3 times rc value, then it will be e power minus 3. So that is what have been here given here, that for 1 tau it is 36.8%, for 2 tau, which means 2 rc, will be 0.135, 4 and 5 it will be 0.0061. And you can observe one thing, when t is equal to single rc, we got e power minus 1, and the value is 36.78%. When t value is equal to 5 times tau, which means 5 into rc, t is equal to 5 rc, means here 5 rc will appear, rc get cancelled, you will get e power minus 5. Okay, for that value we have got 0.0067 percentage. What it says, from the initial value t is equal to 1 times RC, we got 36.8% approximately, and when it approaches 5 tau, the value of stored energy is 0.0067, which means the stored energy of what is stored in the capacitor, that is started approaching value of 0. So approximately it will take 5 times of tau, time constant tau, to reach the 0 value, okay, from its initial value. This is actually called the response of your RC circuit. From the initial value, the rate at which the stored energy is discharging is in terms of e power minus t by RC, and at approximately at 5 tau you will get the value is 0. Okay, so here there is no change, and once it reaches 0 there is no change in the voltage, right? These two may be called as a steady state response. Steady state means there is no change happens. But from here to here, okay, what will happen? This keep on decreasing exponentially, depends on the t by RC value. So this response is actually called transient response or temporary response, that is the stored energy is keep on decaying or changing. That is a temporary response or transient response of a RC circuit. Total response can be calculated by the transient response plus steady state response. We will discuss that later. So for now you just understand, steady state means there is no change either initial or at the end, but transient means that is keep on changing or temporary response between from here to here. That is actually called transient response. So what we have identified in source free RC circuit is, whenever there is no source, which means the source is suddenly disconnected from the circuit, then what will happen? The stored energy in the capacitor that starts discharging through the remaining elements. How the rate of discharging happens is in terms of t by RC, e power minus t by RC. Since we have only one R in the circuit, it is R into C. If we have 2 to 3 or more resistance in the circuit, then we need to calculate that equivalent resistance of the total resistance. Then we need to calculate the what is that called, rate of discharge. Okay, and that is what we are going to see in the problem also. Okay, so this is all about source free RC circuit.